Okay, so we're going to talk about function notation, evaluating from a graph and table, and writing its meaning. So first we're going to look at the we will statement. This is the same we will statement as our previous function notation notes. We're still evaluating functions expressed in function notation, giving one or more elements in their domains. But this time we're focusing on how do I determine a value input or output from a graph and from a table. So we're going to focus on the graph first, and not only are we going to evaluate our input or output values, we're also going to be writing out what does this mean when I write it in a complete sentence, because like I've stressed before, you have to be able to communicate in words spoken or written what this means so that somebody can understand. So that is part of thinking like a mathematician. So if you look at our first graph, we have snail speed as a function of time. So I want you to look at your x-axis. Those are your input values. So we're going to make a note over here that these are input values. Okay, so these are going to go inside the parentheses. Okay, if we hit a number on the x-axis, that is going to give us our input value. And these are measuring time in seconds. And that's going to play an important role when we start writing our meaning. We need to know what unit of measurement we're using. And then if we look over here on the y-axis, we are calculating speed. So these numbers are our output values, and they are calculating the speed of the snail, and the speed of the snail is measured in centimeters per minute. And I think they used a smaller measurement system for length instead of miles because snails don't move very fast. Okay. All right, so let's look. We want to evaluate f of 7. So I want to ask you, is 7 your input or your output value? Hopefully you said your input value. You would be correct. So I know that I need to go to the x-axis, and I'm going to put a little x up here, x-axis at 7, and then read off from the graph line what my y value is. Okay, so I'm going to go to my x-axis, and it looks like 2, 4, 6, 8. I don't see 7, but I do know that 7 is halfway between 6 and 8. So I'm going to go halfway, and you can follow the grid line that's barely visible, and I'm going to go up until I hit my graph here. And now I've got to go to the y-axis to read my output line. So I'm just going to go back to the y-axis, and I hit the number 10. So f of 7 is equal to 10. Well, what does that mean? Well, 7 what? What was the 7 measuring? 7 seconds. So I can say at 7 seconds, what happened at 7 seconds? What about the output value? 10. What is 10 measuring? 10 is talking about the speed of who? The snail. So I can say the snail's speed was 10 centimeters per second. That's what this means. Not only is it telling me my input and my output, but now I can actually put meaning to those numbers, those input and output values, because now they are measuring quantities. Okay, the X's are measuring time in seconds, the Y's are measuring speed in centimeters per second, per minute. I'm sorry, per minute. I need to change that to an M. Per minute. Okay, so let's look at the next one. F of 6. So is this my input or my output value? If it's inside parentheses, it needs to be your input value. All right, so 6. So I'm going to go up to my graph line because I'm at 6 on the input. Go up to my graph line here. And now I'm going to go over to the y-axis. And it's not quite going to reach 10, but it's going to be pretty close. So I've got to estimate. I need to come up with a y value that is pretty close to 10, but not exactly 10. Okay, so I think 9.8 might be good. So this is saying, so we're going to kind of follow the same format as the meaning we just wrote. At 6 what? At 6 seconds. What is it telling me at 6 seconds? Well, what does the 9.8 tell me? The 9.8 came from the y-axis. Well, what is that number? What are those output values measuring? There's measuring the speed of the snail. The snail's speed was 9.8 centimeters per minute. Okay. All right, so now look. They didn't tell me what my input value was. Now they gave me the meaning. So they said after 12 seconds, the snail was traveling 8 centimeters per minute. So now they've given me my input and my output value. Now I just need to write it correctly using function notation. So again, I'm going to go to my little cheat sheet up here because I wrote my inputs were my x values, and what were those measuring? Seconds. So did they tell us how many seconds was going on here in this problem? They sure did. They told me 12 seconds. So there's my input value. So that would be f of 12, because remember, your input value has to go in the parentheses. So if 12 is your input, what does that make the 8? It makes it your output value. So f of 12 is equal to 8. And what these mean, it means after 12 seconds, the snail was traveling 8 centimeters per minute. Okay, so let's look at number 11. So, I'm sorry, f of 11, not number 11, f of 11. And this is my input value because it's in parentheses. So now I'm going to go to my input number line, and I'm going to find 11, which is halfway between 11 and 12, and I'm going to go up till I hit my grid line, or my function line, and now I'm going to go over to the y-axis, and it looks like it's going to hit about halfway between 8 and 9. Well, what's halfway between 8 and 9? 8.5. And now I want to write the meaning. So I'm going to follow the same format as the others have been. At 11 seconds, the snail's speed was 8.5 centimeters per second. I'm sorry, minute. I keep wanting to say second. Per minute. Okay. They gave us, now we're going to figure out the next one, and they gave us the meaning, but they only gave us part of it. So now we've got to figure out how many seconds, after how many seconds was the snail traveling 7 centimeters per minute. And then we have to write it in function notation. Okay, so if this is centimeters per minute, I know that this is my output value. So I'm going to go to my output line at 7, and I'm going to do the same thing that we would do for the input. I'm going to go across and follow that grid line until I hit my graph line. I hit it. And now I want to figure out, well, what is that output? So to get to my output line, I go straight down. And what number do I hit on the output? I'm halfway between 0 and 2, so that means it would be 1 second. So after 1 second, the snail was traveling 7 centimeters per minute. Now that I know my input and my output, I can now write in function notation. So I'm going to go ahead and leave some empty parentheses. And which value is going to go in the parentheses? The input value. And the input value has to be the seconds number, which is 1. And that means the 7 is the output. So f of 1 equals 7. And that means after 1 second, the snail was traveling 7 centimeters per minute. Okay, let's look at evaluating a function from a table. It's even easier, guys, because all you have to know is which column or row, if it's a horizontal table, tells you your inputs and your outputs. If it's a vertical table, your inputs are going to always be on the left because those are where your x values are, and your output column is always going to be on the right because those are your y values. Okay? So now we're just going to do the same thing we've done before. So now I just need to know which column I need to look in, and then we're going to write the meaning. So the first one, f of 3 equals. Okay, is 3 your input or your output? Input, because it's in the parentheses. So I'm going to go up to 3 in my input column, and when x is 3, the charge is $28. Okay, so now I'm kind of looking at the other meanings that they wrote. So they started off the delivery charge for, and then they put their miles number. So what was our miles number? Which number was our miles? Was it 3 miles or 28 miles? It was 3 miles. So the delivery charge for 3 miles is $28. And I know it's $28 because it's telling me a charge, and I also see dollar signs in my output value column. All right, let's look at the next one. F of 1 equals. So if it's inside the parentheses, it's an input value. So now I'm going to go to my input and find 1. And what is the output? It is 14. So the delivery charge for 1 mile is $14. Okay, there's other ways you could say this. I was just kind of using the meaning that they were given or giving to us in one of the examples to kind of help me create my meaning sentences. So now it looks like they've given us the meaning, and now we have to write it in function notation. So the delivery charge is 5 miles for $42. So I'm going to go ahead and write F of equals, and now I just got to figure out which value is my input, which value is my output. Well, if I go up to my little table and I look at my X's, my input values, what are they measuring? They are measuring miles. So if I see miles in the sentence, that number is my input value. Well, which number is referring to miles? The 5. So F of 5 equals 42. All right, here we go, the next one. F of 4 equals. So they've either given me my input or output, and now I have to write the meaning. So is 4 your input or your output value? If it's inside the parentheses, it is your input value. So 4 is your input, so go to your table at 4, and your output is 35. So the delivery charge for 4 miles is $35. Okay, and the last one. So we don't have function notation, which means we're going to have to write it, but they had to have given us the meaning. And here's our meaning. The delivery charge for blank miles is $21. Okay, they didn't tell me the number of miles, so they did not give me my input. They gave me my output value. It's the cost. It's my output, just like on the last example from the table. So I have to now go to my output column and look for $21. There it is, and now I can see what that input value is, and it's 2. So the delivery charge for 2 miles is $21, and now I want to write that using function notation. So F of equals. So now I need to figure out which number is going to go inside the parentheses, which indicates that it's your input value. Well, which one was your input value? Miles, so 2. So F of 2 is equal to 21. And that is how you evaluate a function from a graph or a table and write the meaning in a complete sentence. Remember that you need to use their units of measurement. So you need to know what values or what the X values are being measured in, what the Y values, the output values are being measured in. All right, we're done.